Okay, so I did a video a while back on this this little circuit here. It's a oscillator circuit, and it's kind of nice to use in your projects. I took out they had a place for these trimmer pots, and I added a regular pot on the end of wires so I can hook it up to my project. This is the frequency controller right here, and I noticed that okay, so here it's running, but the problem is, get this out of the way, is that when you run it to the end of the range on either side, this is a 10K pot, the thing will stop oscillating. So what I did is I added some trim pots to, in a clever way, because it took me a few hours to figure this out, so that I can adjust the range, because it would stop oscillating on the top side and the bottom side, the high frequency and the low frequency. Let me demonstrate. I have these tuned up so it will go through the whole range and oscillate. But see, what happens is that during part of the range, when I'm twiddling this knob, it will cut out like that. And that's no good if I'm driving a high power circuit, right? I don't want the power to go high and drive the FET continuously high, because that's what the circuit does sometimes. See, sometimes it goes high like that when it stops oscillating. And so I found with this particular configuration, if I add two trimmer resistors at the right places in parallel and in series with this guy, then I can tune them so that at the bottom side of the frequency and the top side of the frequency, it continuously oscillates as I go through the whole range of this. And there's no position where this will basically self-destruct, because that's something you never want. You don't want a circuit that, if you twiddle the control knob too far, it will self-destruct. And so here's literally a back of the envelope calculation, where this is my main pot right here. And then I have two trimmer pots. So I believe this is the ground side. That's the pin lowest here. I think that's the ground side right there. And correct me if I'm mistaken, but when I'm putting ground there, I'm saying there's three pins. There's a lower, upper, and then a sweeper pin over here. And so this goes to the lower pin, this goes to the upper pin up here, and this goes to the sweeper pin, which is on the opposite side over there. And so if we put a trim pot, these are 10K trim, but I'm only using center tap. Okay, both of these are 10K. I should put that there. 10K, 10K. And this one is also a 10K, 10 kilo ohms. And so if I put one potentiometer in parallel with here and there, that controls the upper cutoff at the high frequency. You can take that no oscillation and get rid of it by trimming that one. And then this other one, which is in series, so this one's in parallel between these two pins, this one's in series between this pin and the output, and that one trims the lower cutoff frequency. And so you can set the upper and the lower cutoff frequency and cut out the dead space by trimming that resistor. And I'm hoping to use this in some projects. I think this is probably my oscillator of choice. It's very simple, very cheap. It covers a pretty wide frequency range, at least in the audio frequencies that I'm looking at right now. And anyway, I hope this helps with your projects. Okay, and there is the final fix to our simple oscillator circuit here. Okay. And anyway, this is Dr. Janes, and thanks for watching.